In this video, we are going to learn about the balance tree. Balance tree is a type of a rooted m-ary tree. We say that the rooted m-ary tree of the height h is a balanced if all the leaves are at the level h or h minus 1. To understand what is a balance tree, first we need to clear the concept of level of a vertex and the height of the tree. The level of vertex in a rooted tree is defined as the length of unique path from the root to that vertex. In simple terms, it is the number of edges from the root to that vertex. For example, in this case, B and C are at level 1 because number of edges from the root to these vertices is 1. For the D vertex, the number of edges from D to A is 2. So in this case, it is at the level 2. Similarly, you can check for the vertex E, F and G. So if you want to reach at the vertex E from this vertex, the total number of edges we need to travel as the 2. It means the length of the unique path from this vertex to A is 2. So all these vertices are at the level 2. Whereas H, I, J, K, L all are at the level 3. Note that the root is always at the level of 0 since there is no edge to travel. Also we can find the level of these vertices. Here we have the rooted graph with the root P. So the level of root is 0. These two vertices are the level 1. These two vertices are at the level 2. These two vertices are at the level 3. These two vertices are at the level 4. And the vertex Y is at the level 5. The next term we need as the height. Height of the rooted tree is the maximum level among all vertices in a tree. So it tells us how deep the tree goes. For this case, what is the height of a tree? The maximum level in this tree is 3. So the height of this tree is 3. For this case, the height of this tree is 5 because the maximum level of the vertex is 5. Now back to the definition of balance tree. We call these rooted m-ary trees with the height h is balanced if all the leaves are at the level of h and h minus 1. In this case, the height of tree is 3 and all the leaves are at the level 2 or 3 because the leaves are H, I, E, F, G, A, K, N. So either they are placed at the level 3 or 2. Hence, the tree in this case is balanced. Now, what about the second case? Whether this tree is balanced? So, leaves are S, U, X and Y. Total height is 5. Whether the leaves are at the level 5 or 4 only? No. Because few leaves are at the level of 2 or a 3 due to which this tree is not a balanced tree. Note that we have another result that is related to the height and the leaves. The first result is for the m-ary tree with the height h, the total number of leaves are always less than equal to m raised to power h. Means there are at most m raised to power h leaves in m-ary tree with the height h. So what does it indicate? It says that the number of leaf is less than equal to m raised to power h. Let's check it whether this result is true for these two cases. In the case number 1, height is 3 and it is 3-ary tree because the maximum number of children for the any internal vertex we have 3. So it means the value of m is equal to 3. Now we just need to check whether the leaves are always less than equal to 3 raised to power 3, that is equal to 27. Yes, because the leaves in this case are 7. and that 7 count is always less than equal to 27. Verify this result for the second case. The total number of leaves in this case is 4 and it is a 2-ary tree. So the value of m is 2 and the height is 5. So leaves are always less than equal to the m raised to power h? Yes. So it means this result is true. Another result we have, if we have m-ary tree with the height h and leaves, the height is always greater than equal to log of L with the base m. We can derive this result from here. What we need to do, we just need to find the value of h. How we can evaluate that? Take the log on both sides. When we take the log on both sides, we have log L less than equal to h times of log of m. From here, h is greater than equal to log of L by log of m. So both have the same base. So we can use the result. We know that log of A by log of B, that can be written as log of A with the base B. Apply this one here and you will get this form. Also note that if it is a m-ary tree, that is a full as well as a balanced. Balanced means leaves are placed at the h or h minus 1 level. Full means every internal vertex has exactly m children. In that case, height is always is equal to this form. Basically, this inequality get converted into equality.